The seamless manufacturing process begins with a solid steel bar that is cut into a billet. The steel bar has a specific chemistry designed for the grade of pipe that will be produced. The billet is cut into a specific length depending on the desired dimensions of the finished pipe. Once weighed, the billets are transferred one at a time to the rotary hearth furnace. The furnace floor rotates clockwise and the billets are heated to approximately 1300 degrees Celsius. The heated billets are removed from the furnace one at a time and transported to the rotary piercer, where the solid round heated billet is converted to a hollow shell by cross-rolling over a high alloy piercing point. This cross-rolling action generates alternating tension and compression forces in the core of the billet. These forces create a void in the center as it comes into contact with the piercer point. The wall thickness of the hollow shell formed at the piercer is then reduced to the final tolerance by longitudinal extrusion on the retained mandrel mill. The outside diameter is rolled down by a chrome-plated tool steel mandrel by a series of 7 reduction stands. The reduction in diameter on the mandrel converts the heavy wall thickness of the piercer hollow into length as it passes through the retained mandrel mill. A mill extractor then decreases the tube's outside diameter further as it extracts the tube from the mill while the mandrel is withdrawn. The pipe now enters a wall thickness gauge where it is scanned by 24 laser beams. The laser beams are triangulated off the pipe surface and provide 12 separate outer diameter measurements. Additionally, there are 9 separate radiographic beams that intersect the pipe to give mill operators 9 separate wall thickness measurements over the length of the pipe. The tube is then transferred into a walking beam reheat furnace. After reheating, the tube exits the furnace and proceeds to the stretch reducing mill. The final outside dimension of the tube is calibrated on the 22-stand mill. Each stand consists of 3 rolls that carefully stretch the tube out to create final outside diameters. The finished outside diameter of pipes produced at Tenaris Algoma Tubes range from 2 3/8 inch up to 9 5/8 inch. The hot roll tube is then discharged onto a cooling bed where samples are cut and sent to the on-site lab for testing. Individual pipes are now cooled to ambient temperature. After cooling, the pipe ends are cropped at the mill's cold saws and then transported to the heat treatment line for quenching and tempering. Here, the specified strength, hardness, microstructure, and impact properties required of high-strength tubular products are developed. The pipes are transferred and loaded into the walking beam preheat and quench furnace, where they are heated to 870 degrees Celsius. Once reheated, the pipes exit the furnace and pass through a water spray quench unit. The unit has 7 spray quench heads, each consisting of 800 individual water nozzles. Then, high-pressure water of the quench heads is evenly applied to the tube as it rotates through the machine. The pipe is now transferred to a tempering furnace where it will be preheated to 510 degrees Celsius, then slowly cooled. This tempering process increases the pipe's ductility or toughness. Precise control of time and temperature during the tempering process are critical to achieve well-balanced mechanical properties in the finished pipe. After quenching and tempering, the pipe passes through a 3-stand resizing mill which calibrates the outside diameter to final tolerances. The pipe is then straightened on a rotary straightener while still hot. Once samples are taken for testing of physical properties, the heat-treated and tempered pipe is transferred to a cooling bed where the pipes are once again cooled to ambient temperature before being ready to proceed to finishing. The finishing process begins with non-destructive testing. NDT practices used at the mill include magnetic particle inspection, electromagnetic and ultrasonic testing, as well as visual inspection. Once the pipes pass inspection, they are cut to length at the mill's cut-off machines, and API threading is performed with computer-controlled threading machines. After threading, the pipe proceeds to final inspection, which utilizes various gauges. The pipes are then transferred to the coupling and buck-on machines, where a threaded coupling is applied to the end of the pipe. Each pipe is then transferred to the hydrostatic tester, where it is filled with water and pressure tested. The pressure applied varies with the type of product being produced, but is normally under 10,000 pounds per square inch. This typically represents over 90% of the maximum pressure rating of the product. Once the pipe reaches its test pressure, the pressure is maintained for a minimum of 5 seconds while the operator inspects for any leaks in the pipe. The finished and threaded pipes then proceed to the weight, measure, and stencil station, where they are weighed, measured, and a final stencil is applied. Reusable thread protectors are then applied to both ends of the pipes. Next, a pipe varnish machine applies a corrosion-resistant coating on the pipe's full length. Once the pipes are ready for shipping, they are transferred immediately onto rail cars inside the plant.